In this lesson, I want to look at a second composition of rigid transformations. In this example, number 2, we're going to look at reflection over parallel lines. You can see the triangle in the figure. I want you to use your imagination that somewhere on this graph we have parallel lines. All right, let me try to do that again. Let's say we have a line that looks like this, and we have another line parallel to it. What will happen to this figure if I first reflect it across the first line, take that image and reflect it across the second line? I'm going to examine this on GeoGebra, but we're going to use either perfectly horizontal or vertical lines. Let's go take a look and see if we can notice something that happens as claimed. So here is this figure. I have two parallel lines there. I have FG and HI. I'm going to reflect this polygon across both of those lines. Let's see if we can figure out what happens. Okay, let me go down to my reflect tool. Reflect about line, first reflecting this figure across FG. All right. And then I'm going to reflect it once again. I'm going to reflect this image across HI. And there it is. Now, it's pretty hard to determine what happened there so far, but maybe we can look at it and then look at other examples. So I want you to see what happened between one of the initial points and the final points. So let's take a look just at A. How far apart, the question really is, how far apart is A from the final resting place A double prime? So let's take a look. How much did this shift from here to here? If we count the spaces, 1, 2, 3, 4, 5, 6. Doesn't seem to be very interesting so far, but I want to point out to you that these lines had a distance of 3 apart from each other. So keep those numbers in mind, and let's take a look at some other examples. What would happen if I were to move those parallel lines a little bit? So I'm going to undo my pin marks. At least I hope I can undo those. Let's see here. All right, let me take a look. What would happen if these parallel lines were further apart? What if I were to move them where they're, let's see, 5 units apart? And let me move this one over as well. Now it's a little bit easier to see those reflections. Hopefully you can see them in order from the right-hand side to the middle to the left. Now what happened to A prime? Let's see if we can count that once again. A double prime, excuse me. So if we start at A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, that moves it 10 spaces, whereas these parallel lines were only 5 spaces apart. So if you continue to explore this, what you find out is the distance between the parallel lines, whatever it is, in this case it's 5, that will, if you take double of that, it'll take this original pre-image to, after 2 reflections, this final image. Again, that's the composition of 2 reflections. And notice the image is exactly the same orientation. It's not twisted, right? Basically, all it did is move it twice as far as the distance between the 2 parallel lines. It's a really cool property, and it holds true if the lines are in a horizontal orientation as well.